All right, this is the last part of 1.7. So you guys are doing great. And guess what? The good news is there's only 2 questions left. Yes. So we just have to get through these 2. I believe in you. Don't quit on me now. Let's finish this off, okay? So this continues on what 1.7 part 4 was going over. How do we solve a linear inequality dealing with an absolute value? So let's look at part C. This one doesn't look like the last 2 examples in the sense that now we have a linear inequality, but it isn't isolated on one side. Okay? So before I even solve this, I have to isolate the absolute value. Okay? So I have to do that first. So in order to do that, I'm going to have to add 13 to both sides. So let's do that first. So when I do that, I get 3 times the absolute value of 2x plus 1 is greater than negative 4 plus 13, which gives me 9. I'm just going to check my math really quickly there. Yes. Okay. So now my next step is to get the absolute value isolated by dividing both sides by 3. So when I divide both sides by 3, I'm going to get 9 divided by 3 on that right-hand side. So I get the absolute value of 2x plus 1 is greater than 3. Okay, now I'm set to go. So again, I'm going to quickly check to see the absolute values isolated on the left. I have a positive number on the right. Now I have to look at that absolute value sign. It is greater than. So if it is greater than, I know I have 2 problems to solve. Okay? So the first problem says that I have to take the 2x plus 1, and I believe we make this the opposite sign, which we do, which is less than here. And then we have to make this constant negative, okay? So you change the sign, make the constant negative, okay? The other problem we're going to get is exactly what it says. So we're going to strip away the absolute value and put 2x plus 1 is greater than 3. So that one's the easy one to come up with, okay? So when you do a greater than sign, change the sign, make the constant negative, and then leave it alone, okay? So let's solve those 2 problems. So let's solve them. I'm going to solve the first one, which I'm going to talk to or call 2x plus 1 is less than negative 3. I'm not going to talk to it. I can't talk to it. So I have 2x plus 1 is less than negative 3. I'm going to subtract 1 off of both sides. Okay. So 2x is less than negative 4. Now I'm going to divide both sides by 2. So x is less than negative 2. Okay, that one's solved. If I write that up in interval notation, all my x are smaller than negative 2. So negative infinity going to negative 2, but not including it. Okay, second one is 2x plus 1 is greater than 3. So minus 1 from both sides. So 2x is greater than 2. Divide both sides by 2. So x is going to be greater than or equal to 2 divided by 2, which is 1. If I write that up in interval notation, it's x is greater than 1. So 1 is the smallest value. Infinity is going to be the largest one. 1 is not included in the solution. So my solution to this is negative infinity to negative 2 union 1 to infinity. Okay, got that one done. All right, let's look at the next one. So again, if I look at this, it's not isolated. And that's the first thing we got to do is isolate the absolute value. Okay, in order to do that, I'm going to divide everybody by 4. So dividing everybody by 4. When I do that, I get the absolute value of x plus 4 is greater than or equal to negative 39 minus 4, which is positive 9. Okay, now I'm good. I got to do a little check here. My check is the absolute value isolated? Yes. Do I have a positive constant on the other side? The answer is yes. And I check my inequality sign and I see that it's greater than, so I know I'm going to have two problems. Okay, so again, when you see that, you're going to have the absolute value, take it away, so it's x plus 4, change the sign, put a negative with the constant. So x plus 4 is less than or equal to negative 9. And then the other problem is going to be take away the absolute value, so we have x plus 4, keep the sign, and keep the constant the same. Okay, so it's x plus 4 is greater than or equal to 9. Now I solve for both. Okay, so I'm going to solve number 1. So I'm going to subtract 4 off of both sides. So x is less than or equal to negative 13. That one wasn't too bad. And if I write that up in interval notation, x values are smaller than or equal to negative 13. So we're going to negative infinity, and then we're going up to negative 13 and including it. Okay, let's do number 2. So I'm going to subtract 4 off of both sides. So x is greater than or equal to 9 minus 4, which is 5. Okay, if I write that up in interval notation, all my x values have to be bigger than or equal to 5. So 5 is included going up to infinity. So my answer is negative infinity to negative 13 union 5 to positive infinity. Okay, guys, I think that's the end. All right, so that's it. Thank you for watching, and thank you for watching all the videos. Try your homework, okay? So that's going to be our next step. Don't forget to submit your notes, okay? I'll be checking them. All right, bye.